Okay, in this lesson we are going to talk about sequences. So what is a sequence? A sequence is an ordered progression of numbers. It's just a list of numbers that have some sort of a pattern to it. So we name the terms in our sequence according to the number of terms. So A sub 1 is the first term, A sub 2 is the second, A sub 3 is the third, and so on. So our 100th term or our nth term would be A sub 100. Okay, so a list is one way to represent a sequence. We can also represent them with a table or a graph, or more common we'll see them represented with a formula. And there's two different ways to represent sequences. With a formula we can represent them either explicitly or recursively. Okay, let's look at explicit first. An explicit sequence is a sequence that's defined as a function of n. So just like we're used to with our functions that we've been studying this year and in algebra courses in the past, where y is a function of x, explicit sequences are just like those. So to find the nth term, we're just going to substitute n into the formula. So here's our first explicit rule for a sequence. We've got a sub n, which is kind of in the place of our y, and in the place of our x, we've got n. So this is real similar to y equals 2x plus 1. Okay, so we've got a sub n equals 2n plus 1. So to find our first term, so a sub 1 is our first term, we're just going to plug in 1 everywhere we see n. So 2 times 1 plus 1, that's 2 and 1, so that's 3. So our first term is 3. Second term, we're going to plug in a 2. 4 and 1 is 5. Third term, plug in a 3, and so on. Okay, so our 100th term, it's kind of convenient. We can just substitute in a 100, just like in a linear function. 2 times 100 is 200, plus 1 is 201. Okay, so explicit rules work just like functions do. On our calculator also does sequences. We want to make sure we switch to sequence mode. If we turn on our calculators and we go to mode, and we cursor down to, so far we've used our function, we've used our parametric and our polar mode. So let's go over to the last one, sequence. And back to our home screen. So if we want to do an explicit sequence in our calculator, we want to go second stat and cursor over to our operations menu down to sequence number 5. And on the 83 and the 84, it's going to look a little different. So on 83, if we're in sequence mode, and we go to second stat, ops, sequence, then notice it just gives us a SEQ and an open parentheses. On the 84, it kind of explains what we're going to plug in here. But we're going to plug in the same thing in both cases. Let me get rid of... It's not going to let me. That's cool. So the first thing we want to plug in is our formula or our expression. Okay, so if we look at this example here, we want to find the first 7 terms of the sequence defined as a sub n equals 2/3 n minus 4, then this is our expression. This is our formula that we're going to plug in first. Okay, so on the 83, I'm just going to do 2/3 times, and then notice when you press the button that usually brings up an x, it's going to bring up an n. Take away 4, and I'm going to put a comma after that. And on my 84, I'm going to plug in the same thing, 2/3 n minus 4. Okay, and then I'm going to press enter on my 84. It takes me down to the variable. So we just need to tell it what variable to plug in. So n is the only one we used. On the 83, I'm going to put a comma after that. And then I want to tell it what term number to start with. Okay, so, or excuse me, what is the first term? Okay, so the very first term, well, that's not true. Term number. So if we're finding the first term, then we want to plug in a 1 there. Okay, and then how far do we want to go? Do we want to take it to the 10th term? Do we want to take it to the 100th term? For these directions, we just want to find the first 7. So we're going to take it out to 7. And in the 83, make sure you separate those with a comma. And then we just want it to step by ones. Okay, and then press enter on both. And then we get our sequence. Now, this is a lot of decimals. If we want to convert it to fractions, we can do math fraction. I think that's going to make it look a little more digestible. So, same thing can be done on both versions. So it comes out like this. So our first term, negative 10 over 3. Second term, negative 8 over 3. Negative 2. Negative 4 thirds. That's our first 4 terms. You can just cursor to the right to see the rest of your sequence on your calculator. Negative 2 thirds, 0, and 2 thirds is our 7th term. Okay, so using our calculator to find terms given an explicit rule. Alright, so now let's go to recursive sequences, or recursive forms of sequences. Alright, so these are a little different than the functions that we've used in the past. The first term is given to us, and then the rest of our formula, or the rest of the terms, are defined in terms of the previous term. Okay, so for example, we want to find the first 6 terms and the 100th term. If our initial term, okay, b sub 1 is 3, and our b is just the same as our a, so we're just naming a different function. And then notice we've got this b sub n, so that whatever that term number is b sub n minus 1. And that just refers to the previous term. Okay, so that n minus 1 with the b just calls on our previous term. So the previous term plus 2, n's got to be bigger than 1, but we've already plugged in we've already got our first term there, 3. Alright, so in our list we can put 3 there, and to find our second term, then we just want to take our previous term 3 and add 2 to it. So our next term is 5, and then for b sub 3, call on our previous term, which was 5, add 2, we get 7, previous term plus 2, previous term plus 2. Okay, now if we want to find the 100th term, one of the downsides of a recursive sequence is that we've got to know the previous term in order to get the next one. So if we want to know the 100th term, then we need to know the 99th term, then we need to know the 98th term, and so on. Okay, so there are some ways around it. If we have a sequence like this, where we're just adding a number each time, then we can think of it as, well, we're going to take 2, or excuse me, we're going to take 3, and we're just going to add 2 99 times. So we take 3, and then we're going to add 99 2's. So that's 3 and 198, which gives us 201 for our 100th term. Okay, a lot of times certain sequences can be written in both explicit and recursive forms. Not all, but most can. And so oftentimes we'll go back and forth between those two. Okay, so recursive sequences can also be done in our calculator. Make sure we're in sequence mode. We just put it in sequence mode. So then go to y equals, and you notice a different looking y equals screen. We've got u of n and u of n min, and n min equals 1 first. So we're going to leave that 1 the way it is. Let's do this first example. We want to find the first 6 terms of this recursive sequence. So underneath u of n, this is our b of n, we want to plug in this formula. The way we do that, the way we call on this u, is if we press second and then our 7 key. Notice there's a little blue u above that. And then just in parentheses, we're going to put in our variable, it's usually our x, that's our n minus 1. Okay, so our calculator knows to understand that as u sub n minus 1, or our previous term, plus 2. And the u sub n min, that's just our initial term, which is 3. Okay, if we press enter, and then if we go to our table, so second table, we've got our term number, and we've got our term in the second column. Okay, so if we go cursor back up a little bit, we see that our term number 0 gives us an error because there is no 0th term. We always start with our first term. So our first term is 3, and if we want to find the first 6 terms, then we've got 3, 5, 7, 9, 11, and 13. So that's the same as the last sequence. Okay. All right, so you try number 2. Find the first 6 terms, and if you want to find the 55th term, then you can either cursor down to 55, or if you go into your table set, just change your table start to 55. And you can find it that way. Okay, so let's practice a couple of these. Number 3 says find the first 6 terms in the 100th term of the explicitly defined sequence. All right, so we're given an explicit form here. We want to find the first 6 terms. So my first term, I want to plug in a 1. So 2 times 1 is 2. 2 take away 1 is 1. And then plug in a 1. 1 cubed is 1. So that's just going to be 1. All right, for my second term, I'm going to plug in a 2. 2 times 2 is 4. Take away 1 is 3. 2 cubed is 8. Okay, plug in a 3 for my third term. 6 minus 1 is 5. 3 cubed is 27. And so on and so forth for my 4th, 5th, and 6th terms. We should get 7 over 64, 9 over 125, and 11 over 216. Okay, and then if we want our 100th term, then we plug in 100. 200 minus 1 is 199. 100 cubed, it's a lot of zeros. So we have 1 and 6 zeros. So that's our 100th term. If you use your calculator to find this, make sure you convert it to fractions. They're a lot nicer to look at than the decimals, okay? And you don't have to round. All right, so I'd like for you to do B, C, and D in your notes. Let's look at number 4. Number 4A. Okay, so let's find the first 4 terms in the 8th term of the recursively defined sequence. All right, so notice with we've got a recursive sequence here. We've got our initial term, and we've got our rule. Okay, so our rule says the previous term plus n. Okay, we've already got our first term, 29, is given to us. Okay, our next term is we're just going to add the term number. So if this is our first term, we're looking for our second term. So 29 plus 2 is 31. Our third term, 31 plus 3, which is 34. For our fourth term, it's going to be 34 plus 4, which is 39. And if we want to find our 8th term, then we can either find the 5th, 6th, 7th terms to find the 8th term, or we can use our calculator. So if we go back into y equals, and we plug in our formula, instead of plus 2, instead of our previous term plus 2, we're going to add n. And our initial value, instead of 3, is 29. So we plug in our recursive formula, and I want to find the 8th term, so I'm going to make my table start at 8. Go to my table, and my 8th term is 64. Okay, so you try B, C, and D in your notes. Okay, there are a few specific type of sequences that occur frequently, and the first one is an arithmetic sequence. An arithmetic sequence is arithmetic if there is a number d such that the second term minus the first term is some constant d, the third minus the second is that same number, and so on and so forth. So if we have a sequence, so let's say 3, 6, 9, 12, and so on. If we can take the second minus the first, so if we can do 6 minus 3, and get the same thing as if we did 9 minus 6, and get the same thing as if we did 12 minus 9, and so on. For any parasequential values, if we get the same thing each time, then that's an arithmetic sequence, and that number there is our common difference, our d value. Okay, another way to look at it that you might have done in algebra class is just say, well, 3 to 6 is plus 3, 6 to 9 is plus 3, 9 to 12 is plus 3. They're the same thing, and we're using addition, then it's going to be arithmetic. Okay, so one of the bonuses for being able to identify a sequence as arithmetic is that we have some general forms, both explicit and recursive, that fits for any arithmetic sequence. So we'll start with explicit. Again, explicit forms are in terms of n. So we've got our initial term plus n minus 1d. Arithmetic sequences are a whole lot like linear functions. They can be modeled by linear functions. So I like to think of it y equals mx plus b. Think of it in slope-intercept form. And I like to rearrange this to where I put my d first times n minus 1 plus my initial value. Okay, to where this is like my m times x plus my y-intercept. Okay, so as long as we know our initial value, as long as we know our common difference, we can find an explicit form for an arithmetic sequence. All right, recursively, if we want to find the recursive form of an arithmetic sequence, we know the initial value, and then we're just adding on our common difference each time. So for this example here, our initial value was 3, and our common difference was also 3. So we would just have the formula a sub n equals, remember that means our previous value plus whatever our common difference is, 3 in this case. All right, so let's work out a couple of these examples. It says determine the following sequences are arithmetic. If so, we want to find our common difference, the 10th term, and we want to define it both recursively and explicitly. All right, so our first sequence, we've got 10, 8, 6, 4, 2. This one's obviously decreasing. So if we use our trick to see if it's arithmetic, 10 to 2 is minus 2, 8 to 6 is minus 2, 6 to 4 minus 2, and that stays the same the whole time. So it is arithmetic. And our d value is minus 2. Okay, if we wanted to find our 10th term, a sub 10, well, we've got 1, 2, 3, 4, 5, so I'm just going to go ahead and list off the next ones. I can subtract 2. So there's our 1, 2, 3, 4, 5, 6, 7th, 8th, 9th, and 10th term is negative 8. Okay, if we want to define it recursively, then we got to have our initial value, which we're given as 10. And since we know it's arithmetic, then we can follow this rule. So our previous term plus whatever our common difference is, since we're subtracting, we can just write minus 2. Okay, we get our next term by subtracting 2 from the previous. And our explicit form, if we follow our rule, I like to use this one, our common difference. So a sub n equals our common difference times n minus 1 plus our initial value. Nope, that's not 3. That's a 10. Okay, and that's our explicit rule. Okay, let's look at one more example, number 2. We've got the sequence 1, 2, 4, 8, 16. 1 to 2 is plus 1. 2 to 4 is plus 2. Oh. Okay, so since those two aren't the same, and if I were to keep going, we'd have plus 4, plus 8. That is not a common difference, so this is not arithmetic. And we don't have to go any further with this one. All right, so in your notes, try 3, 4, and 5. We'll talk about those in our next class. And also on the next page, I'd like for you to do these next 3 examples in your notes. And we'll work those out together, and we'll answer any questions you have in our next class.